across the board. In this case, their density is a density per unit length, or mass per unit length. So it's a linear density.
Friction, density, you can
Yeah.
do everything.
Okay, so for that number 57, you needed to use your tension, okay, which would be just the weight of the mass hanging down. So mg over ml, solve for your velocity, and then once you knew the velocity, you could solve for your frequency. But be aware of this relationship, because again, that's kind of one of those formulas that doesn't appear on your formula page, but it is a relationship that you're expected to kind of know conceptually. In other words, this type of relationship will appear on the multiple choice part of the exam. As you increase the tension on the string, what happens to the frequency, that type of stuff. Okay? Remember, the multiple choice part of the exam is all concept stuff. Very few numbers. And this is why they don't even give you a formula sheet, because you don't need one. So a relationship like this does not appear on your formula sheet because it's a concept that you're expected to know. But if you see it in the free response part of the exam, they'll give you that formula in the problem. They've done that in the past.
So for 57, will you just use mass of the string and the weight?
Now, well, the mass of the string for the short length is negligible. So it's just going to be the weight at the end of the string. In other words, you've got this. You've got 5 kilogram mass. Okay, the weight of that mass is providing the tension. Okay, and then the density per unit length, you're told that is a 20-gram wire, which is 1.6 meters long. So your mass would be 20 grams, which is 0.02 kilograms over 1.6 meters, and then your tension would be 5 times 9.8.
So we don't need, because I need to find out 5.1 kilograms.
5 kilograms times 9.8, because it's a weight, it's not a mass. And then the string, this is the density of the string, not of the weight at the end of the string, but just the string. You're told the string is 20 grams for 1.6 meters. Okay, so again, that relationship is a good one to tuck away. It's kind of like the other one we had on the board yet, for the intensity is equal to power over area. Because again, those relationships are the kinds of things that the AP tuck away inside the multiple choice test questions. And they say they're legitimate questions because that's the concept. Intensity is the amount of power extending through a particular area of space. The velocity of a wave in a string depends on the tension and depends on the mass per unit length in that ratio.
On the free response part of the test, if they were to ask us a question about like open tubes or closed tubes, do they have to give us the actual formulas we use?
No.
No?
Okay, because the formulas are just the relationship substituted with the wave equation. They gave you the wave equation. So what you need to know is, for strings and open tubes, 2L is equal to lambda. For closed tubes, 4L is equal to lambda. And then substitute that through the wave equation. So this is the concept, okay? Which is not a formula. It's the concept relationship. And then the formula, you just take your wave equation, which they do give you, and substitute it that.
You just multiply it by the frequency, by the n.
Yeah, and N is this, because you can have multiple modes of oscillation. This is the mode of oscillation. Okay. And in this one, because you've only got odd numbered multiples, you need that odd number generator. Or you could say N here, but you have to know that N is equal to 1, 3, 5, 7, 9, 11, only odd numbers. Okay, so 457, answer came up as 19.5 hertz. once you found the velocity using this, and plug it into here. Your fundamental would be 1, length is 1.6, all through frequency. And other than that, the rest of them are just kind of pretty straightforward substitutions. Any questions? 63. 63. Calculate the fundamental of the first 3 overtones of a hollow pipe 25 centimeters long, closed at one end. Okay, I didn't talk about overtones. You have your first harmonic. Is the fundamental. And then your second harmonics, third harmonics, fourth harmonics, and so on, these are all your overtones.
I kind of assume that.
So, for instance, for a musical instrument, they are pretty much set to play at the fundamental mode. But if you really stress the instruments, then what you will get will be all these overtones laying into the fundamental. And that's kind of the difference between your virtuosos in music and the normal guy who just plays it on weekends, is they can get the overtones laying over top of the fundamentals and really enhance the sound. So for 63, it's going to calculate the fundamental of the first 3 overtones. I've got a closed tube relationship. So my relationship is going to be, my frequency is going to be equal to 2n minus 1 times velocity over 4L. Okay? My first, which is going to be my fundamental, n is equal to 1, so 2 times 1 is 1 minus 1 is 1. For my first overtone, which is my second harmonic, I'm going to have 3. For my third overtone, which is my second harmonic, I'll have 5. Okay, because of that odd number generator, in my second harmonic, 2 times 2 is 4 minus 1 is 3. In my third harmonic, 2 times 3 is 6 minus 1 is 5. In my fourth harmonic, I'll have 7. Given in the problem is the length, 25 centimeters. And it is a tube, so the medium for the wave is going to be air. And you just assume air at room temperature, which will be 340 meters per second. And on the AP exam, 340 is also kind of the default.
So the second harmonic is the second overtone?
Now, the second harmonic is the first overtone. So your overtones begin with the second harmonic. Okay, your fundamental is the first harmonic, and then second, third, fourth are all overtones.
I'm study tool. I can play it back and I don't get any of this. I'm serious.
Okay.
I mean, if you don't mind, I'll turn it off if you want, but you sure?
It reminds me when I went to college, portable tape recorders were just coming in. So all the pre-med majors used to take the tape recorders and put them up on the desk.
That's a pretty good idea.
I mean, I'll put on YouTube if anyone wants it. You're a celebrity, Mr. Detzer.
So it's just the next level of technology. It's
Put it on YouTube.
amazing.
Just put it on
Of course,
YouTube.
when I went to college,
It's time to study with Mr. Detzer.
I'm surprised I went this long without you noticing. Not really, actually.
No, I think you know
I don't even know what that is.
No, he's
Your
big
father
on
must
YouTube.
have one. Or maybe not.
He does. I mean, he's electrical engineer.
Yeah, I know he's an engineer. So ask
Well,
him.
now that the need for Alex
I'll bring one in.
secrecy is gone, can you move the damn thing?
It's been a long time
I
since
can't look
I've
at this.
used them, because as soon as you find a calculator, you never go back to the slide.
Calculators have made everyone dumb, I feel like.
Exactly.